How blockchain works step by step. Decoding blockchain, the safeguard of your finances, database, property, and more. In 2017, cryptocurrency's valuation rose from $1,000 to $20,000 straight, and another profession emerged in the world: crypto traders. And yeah, crypto trading indeed made a lot of money for people. Yet, blockchain technology is way beyond transferring finances. Rather, it's beneficial in sectors like healthcare, elections, public welfare benefits, insurance, gambling, and artist or writer's royalties. We can say that if today you are thinking about exploring the potential of this blockchain revolution, you are not late. Just Google about the world's 10 largest companies, which are incorporating blockchain into an array of products. In law, blockchain can help develop smart contracts and digital contracts, validate ownership documents, and secure courtroom evidence that can improve different justice systems around the world. Similarly, cryptography is another method of blockchain which helps secure data from unauthorized access. For secure transactions between two nodes in a blockchain network, the two leading players are cryptography and hashing. You can find more blogs about each subject related to blockchain on this platform. Now, let's dive deep into a step-by-step guide on how blockchain works. What is blockchain? Blockchain is a chain of blocks, voila. Alright, on a serious note, it is a chain of digital blocks, and when we say digital blocks, it means data. Any data that is stored digitally in the form of blocks, when kept together, become a blockchain. And hence, that data becomes immutable, meaning that the information stored in it can never be changed again. Quite revolutionary, right? Imagine that you want to keep a safe record of your data, be it your property rights, your medical records, your identification, your money balance, or possibly anything. You can store it in the form of blockchain and will never be at risk of getting tampered by anyone. That's what makes cryptocurrency a revolutionary technology to make and store money. This article is your beginner's guide to blockchain technology and how you can make money with blockchain. Let's dive deeper into the steps now. Step 1: Data transaction. The name is simple, but let's understand it with an example we all have heard of. The Bitcoin blockchain, the oldest blockchain. Each block on this blockchain consists of 1 megabyte of data approximately. Let's say that while writing it counted as about 525,000 blocks, so roughly a total of 525,000 megabytes was stored on this blockchain. This data on the Bitcoin blockchain makes it an exclusive transaction data and keeps a giant track record of all the Bitcoin transactions ever made, right from the beginning of the very first Bitcoin transaction. In this blog, let's assume that a blockchain stores transaction data similarly to the Bitcoin blockchain. Step 2: How blocks are chained. Let's now imagine 3 blocks individually containing some transaction data. For more simplification, you can imagine a Word document that simply describes what transactions were made and how certain balances were impacted. Document 1 describes the first transactions up to 1 megabyte, Document 2 describes the next transaction up to another MB, and so on. So, now you know that these documents are what we refer to as blocks of data, which further will be linked or chained together. To perform this task, every block gets its unique signature, which we call a digital signature. A digital signature corresponds to the string of data stored in that block. If any alteration ever occurs to that block, be it a single digit, the digital signature also changes. How does this happen? This is exactly what we are learning in our third step, which is called hashing. Step 3: What is hashing? So, take another example. Let's say, John sent $200 to Ben and this specific transaction requires a signature. Blockchains create signatures by a cryptographic hash function. A cryptographic hash is a complex formula that converts any string of input into a unique 64-digit string of output. Let's say you inserted the word vegetables into this hash function and you will get output for this specific string as 761A7347C7C127F1730256F700D415F0D3199868. Now, if any single digit gets changed in the input string, even if it's just a space, a small letter into a capital letter, or adding a full stop, for example, the output will be totally different. If you remove the last letter of the above word, and it becomes now vegetable, you will see that the output for this specific string of this string will be different as below. B9B324G2F987CD407632499660D4071DG72D99810409580FEC291B. This is just an example to make you understand things with clarity. Step 4. How a block is signed. Not always a signature gets qualified. Let's say that a block will only get accepted into a blockchain if the digital signature begins with a consecutive number of 10 zeros, 000, 000, 0000, for instance like this. Only those particular blocks with a signature of at least 10 such zeros will be qualified to add to the blockchain. However, as mentioned above in step 3, every string of data has only one unique hash formula to it. What if the signature, hash, of a block doesn't start with 10 zeros? Well, in order to make the block eligible as a requirement, the data string of the block needs to be changed repeatedly until it leads to a signature starting with 10 consecutive zeros. However, you also need to keep the data string the way it is, and so you can only add a very little specific piece of data to each block which has negligible and no purpose except for bringing some alterations in order to make the signature eligible. This type of data addition is called the nonce of a block, a completely random string of numbers. The process of repeatedly adding the nonce to a data is called mining. Step 5. What makes a blockchain immutable? As mentioned earlier in step 3, altering a block will always give it a new digital signature and the existing block gets unchained from the subsequent blocks. So, in order to make an altered block be accepted by the rest of the network, it should be chained to the subsequent blocks again. See what this means? We have previously discussed that every block needs to meet the requirements of specific digital signatures. And once an alteration is made to a specific block, it will be too costly and time-consuming to give it a new signature that gels with the blockchain it belongs to. However, it doesn't seem impossible. Anyone who would want to do it will consider it impossible. Step 6. Who governs blockchain? The Bitcoin blockchain is followed by a governance model, and this model is called the model of democracy. This model updates its record of transactions by the truth, as it is said. After all, altering any blockchain requires a huge computational power to create the longest version of the blockchain. And that is why an altered block gets automatically rejected by the majority of the network, since we know that it won't be chained to the network anymore. So, we can say that the governance is quite true to its value and blockchain is secure to use. Step 7. Where cryptocurrency is stored. Although most cryptocurrencies are usually an altered version of Bitcoin, these have their own blockchain network with different rules from the Bitcoin blockchain. For instance, Bitcoin is / a currency that explicitly functions as money. However, another cryptocurrency called Monero has a blockchain protocol that makes the transactions harder to trace. Cryptocurrencies can be given any kind of value, such as a gaming license, usage of electricity or water, you name it, and crypto can be issued that value. Once these cryptocurrency transactions get registered on a blockchain, these can be exchanged online and can act as new money of the internet. Let's sum up the article by saying that blockchains are not just limited to registering materialistic data. The safe registration of medical records, historical records, tax payments, and much, much more can be achieved by this blockchain technology. It's huge, and this blog is just meant to give you a gist of it. Beginner's Guide to Blockchain Technology, 10 largest companies that are incorporating blockchain, smart contracts and digital contracts, cryptography, nodes in a blockchain network, how blockchain works, how you can make money with blockchain, blockchain is secure to use, new money of the internet.